Okay, this is the 12 p.m. Zoom meeting, February 25th, 12 p.m. in section 5.3 this week. And it is the independence and the multiplication rule. Okay, I think just trying to work through some problems. Oh, we have a participant. I don't have your name up here. Would you like to identify yourself?
Yes, it's Evelyn.
Okay. Do you have any questions? I was about to charge into some problems because I didn't know anybody was here, but I happened to notice someone, yeah, you came. So would you like to see any problems?
Yes, practice problems would be fine.
I'm sorry, which ones?
Whichever, the ones that you were about to go through.
Well, I was just about to go through problems in the book. I've done basically 11 and 13, so I was about to, just kind of work my way through the odd ones for about 30 minutes. Is that okay, or have you got something more specific you'd like to see?
That's okay.
Do you have anything from the MyLab you'd like to see?
No, not at the moment.
Okay. Well, if you do, stop me, let me know. I try to keep track on the screen or listen out for you. I guess I'll charge into page 259, then number, say, 15. It's tough to write all this down, it's a lot of words. But they're talking about, I can call it the ELISA test. It's a test to determine whether HIV antibody is present. In other words, if someone has HIV or AIDS. Test is 99.5% effective, which means the test will come back negative if the HIV antibody is not present 99.5% of the time. And you could say it's accurate 99.5% of the time. It has a 99.5% accuracy. Probability test coming back positive when you're not present, that's a false positive. In other words, the test is an error, is 0.005. So we give the ELISA to 5 randomly selected people who we know do not have HIV. So what's the probability that the ELISA comes back accurate, negative in other words, for all 5 people? Okay, so probability, basically an accurate result. For all 5 people. Well, there would be 5 slots. And we want it negative on all 5 slots. In other words, test to come back negative because these people don't have HIV. And you can see that's 0.995 each time. We are again going to assume this is independent. That one person being negative has no effect on another person being negative. And if they're widely separated people, you can shorten this up by going 0.995 raised to the 5th power. .9752. 97% chance it would come back accurate. All right, what is the probability that the ELISA comes back positive for at least one of the 5? There's that at least again. This is a probability positive, which basically means an error, for at least of 5. Okay. This is a complement event. To this. These are complements. Now, it is obvious to me that they are complements. Is that obvious to you, or do you need explanation for why they are complements?
I need an explanation.
I apologize. Volume is low or something. Can you say that again?
I said you can explain it, please.
Oh, okay. Well, you have to kind of sketch at least the beginnings of the chart to get it. But you can't do the whole chart, because with 5 people, and again, 2 results, positive or negative, you're going to have 32 rows. So in effect, they've asked about the first row. Part A here has asked about the first row. The probability on this is 0.995 raised to the 5th power, because you got 0.995, 0.995, blah, 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 5 times. All right, and that's going to come up 0.9752. We found it. All right. This is going to go for 32 rows, 2 to the 5th power, meaning the next row will go 9, negative, 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 and then a positive. All right, well, I'm not going to sketch out all 32 rows. It's going to end with all positives at the bottom here. All right, can you see every one of these rows has at least 1 positive?
Yes.
Do you see that?
Yes.
So to figure this directly, or the long, slow way, we've got to account for all 31 rows here. Meaning this row would go 995, 995, 995, 995, then 0.005. And you'd multiply that out, you get row 2. There'd be similar thing until down here at all positive, it's 0.005 to the 5th power. All of these are 0.005. And we would have to do 31 rows of this. But very slickly, this fits the definition of a complement. It's everything else in the sample space, not in the original event. So slickly, we can get our answer from 1 minus 0.9752. In other words, 1 minus row 1, which was the answer to A. That's why he did this. He had you do part A and get that answer, and then you could very slickly recognize B as a complement and get your answer from doing this. 1 minus 0.9752, 0248. 2% chance you'd have at least 1 false positive result, and that's what he has. If you can look, I don't know if you can get the glare off. Yeah, right here. Yeah, 0248. So that is the very slick way of doing that. Does that make any sense?
Yes, that does.
Okay, so he follows this pattern a lot on a lot of these problems. So we can continue on. Let's see, go to the next page and we hit 17. This is about life expectancy. All right, for a 40-year-old, randomly selected 40-year-old male, the life expectancy, or the probability they'll live to be 41, is 99757, okay, according to a reputable statistics report. So the two events in 17 are basically live and die. This is a 40-year-old going to a 41-year-old. And they give you the probability of, I'll shorten it to L, of living is 0.99757. But, you know, there's no guarantees in life. There is a chance a 40-year-old would die. And can you see that's a complement event? 1 minus 0.99757. 1 minus 0.99757. 00243. All right. They give you this, but you're going to need this. All right. A. Take two 40-year-olds. What is the probability both live to be 41? Probability both live. All right, can you see? You'd have 0.99757 in both slots. You can multiply all those digits out, or you could shorten it up and go 99757 to the second power squared. 0.99757 squared. 99151. 99% chance. Do you want to see the other parts?
Yes, please.
Okay. So B jumps it out to 5 people live. 5 40-year-olds live. Well, that's just going to extend it. 0.99757 in all the slots. So that's going to extend it to 99. Golly, it's 757, my fault. Dyslexic today. 99757 to the 5th power. Point 99757 raised to the 5th power. 9879. 98% chance. Someone would live, of all 5 would live. Okay, so C has 2 things. Another at least. Find probability at least 1 of 5 not live. Say does not live, will not live. All right, do you recognize that as a complement to this?
Yes, I do.
Okay, you have to draw the same kind of chart as the last problem, same rows, 32 rows, because it's got 5 people. But just the percentages have changed, but you still got 2 events, live and die, instead of being positive and negative. So this is very slickly, we'll go 1 minus 0.9879. 0121. At least, or as a 1% chance, one of them wouldn't live. All right, then in the same part, is it unusual? Basically, they're asking, is this unusual? They're talking about this. They're repeating the same thing. If at least 1 of 5 did not live. All right, do you remember our criteria for unusual?
Yes, is it 5 below?
0.05 or below, less than or equal to 0.05. And yes, this is 0.01, so very clearly this would be unusual, yes. Yes, unusual. Yeah, you'd be surprised. Whoa, how'd that happen? Somebody died. It's only 40 and he died, man. Okay, do you want to keep going?
Yes, please.
All right, some of these are a little hard to read. 19 talks about financial derivatives. They try to give you a little lesson on that. I need it myself. I have no clue what the heck. So they're trying to give you a little lesson on it. In finance, a derivative is a financial asset whose value is determined or derived from a bundle of assets, such as mortgages. In other words, they've bundled a bunch of mortgages and have sold them as one derivative. We have a randomly selected mortgage as a probability 1% chance of default. So let's write that down. So this is going to be pretty much default or not default. It's pretty much two things going on in each problem, positive or negative. Last problem is live or die. This one is going to be basically default or not default, I guess, for lack of a better way to express it. Good standing. All right, and we know the probability of a default, shorten it up to D for default, is then 0.01. So I'll use ND for not default. Can you tell that's 0.99, the complement?
Yes.
Okay. So we go to A. In fact, I just answered A. What is the probability of randomly selected mortgage? Find probability that someone will not default. And sure enough, I just did it, 0.99, 99% chance someone won't default. All right, what is the probability a bundle of 5 will not default? So probability 5 not default. Well, can you tell that's going to be 1, 2, 3, 4, 5, each 1.99 for all of them, making 0.99 to the 5th power. .95. They rounded up to 0.951. Book uses 0.9951. Either one, 0.95 or 0.951 is fine. Questions about that?
No, that makes sense. Thank you.
Okay. All right, so what is the probability at least one? Yeah, see, they're wording this badly. They really should say at least one of the 5. They're really referring to B, but they're not explicitly saying at least one mortgage defaults. They really should be saying at least one of the 5. So we'll assume that's what they mean. Find probability at least one of 5 defaults. And do you see that is a complement to this?
Yes.
So we can do it as 1 minus 0.951. .049. In part B, we made the assumption that the likelihood of default is independent. Do you believe this is a reasonable assumption? It's hard to know what they're going for. Okay. I don't know, it just depends on the situation. It's hard to write down. If you're using mortgages and one's in Atlanta and one's in San Francisco, it's completely different companies. Yeah, it's probably a reasonable assumption. If you're doing like row houses around a plant, and the workers live in the plant, in houses that, surround a plant, the plant goes under, the coal mine goes under, this really happens in coal mining town, or something. The mine, they shut it down, quits quits functioning, then, the workers don't work and they can't pay their mortgages. So it seems like it would be pretty well related. So it's hard to express all this. It totally depends on the situation. I try to avoid those kind of questions on the test. Don't thank me all at once. Are you ready for the next one?
Yes, would we do 5.4 for this quiz, or is it just 5.3?
No, it's just 5.3.
Okay, thank you.
Yeah, we're going to have 10 problems on tomorrow on 5.3. That'll be the quiz for this week. Next week, there won't be a quiz on 5.4. There'll be the test on chapter 5 next week. Because 5.4 will finish the chapter.
Okay, thank you.
We have another person who's joined us. Do you have any questions? I don't have your names on my screen in front of me. So the new person who's joined us, do you got any questions? If you're trying to talk to me, you're muted. I can't hear anything.
No, please.
Okay. Y'all want to see the next problem, 21?
Yes, please.
Okay. All right, this is where things, again, it's hard to write all these problems down. There's so many words. I'd be here another 10 minutes copying this down for you. We kind of give the author of the book a Captain Obvious award here. In airline applications, failure of a component can result in catastrophe. Gee, you don't say. It's called the airplane crashes. Okay, so as a result, many airline components utilize something called triple modular redundancy. This means a critical component has two backup components. May be utilized should the initial component fail. Suppose a certain critical airline component has a probability of failure, 0.006. Let's write that down. Probability of a failure, I'll use an F, failure, 0.006. And the system utilizes the component as triple modular redundancy. All right, we're going to need the probability that it not fails or that it's good. Can you tell that would be 0.094? 1 minus 0.006, 0.994. So this problem, it's something fails or it doesn't fail, not fail, it stays good. Assuming each component's failure or success is independent of the others, what's the probability all three components fail, resulting in disaster for the flight? Meaning, woo, pew, crash. Sorry if you've known anybody in an airplane crash. Yeah, it's not good. Basically, they want probability all three fail. All right, so that would be 1, 2, 3, 0.006, 006, 006, 0.006 raised to third power. This is going to be a small number. In fact, the calculator probably won't give it to me straight. We'll have to explain what it does give to me. 0.006 raised third power. Okay, notice what I get. I hope you remember your scientific notation. 2.16 e negative 7. All right, do you all remember your scientific notation? 2.16 is a way of writing very small numbers. The e stands for times 10 to the negative 7 power. Since this is negative, this is a small number. And I move this decimal place left 7 places, one of which is the 2. First one's the 2. This is the first one. So I need 6 zeros. 1, 2, 3, 4, 5, 6, 2, 1, 6. Questions about that?
No, sir.
Would y'all put your hands right in an airplane knowing that's the probability of something that's going to fail and you're going to crash? Millions of people do it every day. Don't even think about it. All right, so basically find probability at least one. They're using does not fail, or at least one is good. I'll use is good. They're wording it does not fail. At least one does not fail. All right, can you tell their complements? So you can get it from 1 minus 0.0000216. If you want to match the book, better write out all those digits. 1 minus 0.123456216. 0.99999. I think there's 6 nines there. Yeah, 784. So that is your chance that at least one of the parts will stay good and y'all can stay in the air and not crash. And people stake their lives on this kind of probabilities every day. You imagine being the very first guy getting in an airplane, one of the Wright brothers, having no idea if it's going to work or not. But they get in an airplane and they shoot themselves down the runway, try to fly, and no idea if it's going to work. There's a lot of people who kill themselves trying to figure out how to fly. If you look back at it, it really is. It's amazing. But they knew there was glory in it if they could be the person who could figure out how to fly. Questions about this?
No, sir.
Okay. Was there a C? No, there's not a C. That's it for 21. What did I do on the assignment? I go through, I went through 31. Do you want to see more?
I think I get the gist of it.
Think you get the gist of it?
Yes.
Okay. Our other person out there, we're at almost 30 minutes. Not that I have to end at 30 minutes. I'm perfectly willing to show you as many problems as y'all want to see. We have the Zoom meeting at 8 p.m. tonight. If we quit at 21, I'll probably pick up with 23 and finish. Unless y'all want to see them now. The other person here, do you want to see any more?
No, please, it's fine. We can continue at 8.
Okay.
Yes,
So are we
please.
ready to end the meeting then?
It's fine.
Okay. I will be back here at 8 p.m. tonight. If y'all want to see any more, feel free.
Yes, I wish to ask a question.
Sure.
3 point. It's like 3 point. I think 3.5. Is it 3.5?
Oh, this is off my lab?
Yes, of my life. I don't really know the homework on it because I watched the video there. I cannot see the numbers that I'm supposed to do. I think 3.5. I think so.
Yeah, there's usually a third number. This is off my lab. 3.5. Is there a third number, point something?
I mean the numbers that we're supposed to do because you gave I think you gave the numbers for the other ones.
Oh, okay. You want the MyLab problems for section 3.5.
Yes, please.
Okay. Well, I don't have them in front of me. I'll get on D2L
Okay.
In fact, if you
Because
want to get
I
on
saw-
D2L, it'd probably be quicker than me if you don't want to wait for me. But if you get on D2L,
Okay.
look in the left column under assignments,
Okay.
and you should be able to find,
The various problems, right?
it's in the left column, and yeah, you'll see all the assignments are listed in order for the entire semester.
Okay.
And yeah, you
Interesting.
should be able to click on the one for 3.4 and 3.5. Yeah, we did those in 1 week, so it'll have both 3.4 and 3.5 listed, and you can find them there.
Okay. Thank you so much.
Everything I emailed to you is backed up in D2L.
Okay.
That's so my bosses can see it, because they can get on D2L and actually see that I'm actually earning my money.
You are. Thank you.
It's kind of amazing. If you look, all the Zoom videos are there. It's kind of, you look through and you'll see how many Zoom videos we've done so far.
Yeah, actually, I watched the Zoom video on this, but I can see only 3.5. The problem you listed there, but I can't see 3. I can see only 3.4. I can't see 3.5. That is why I asked.
Okay. Well, I'll get on there and I'll email it to you. Okay.
Okay. Thank you so much.
Okay. Okay. Yeah, I sure will. Is there anything else y'all want to see?
No, please.
Okay. Well, I'll do that pretty quick for you.
Thank you so much.
Okay. Sure thing. All right.
All right, thank you. Goodbye.
Thank you.
Goodbye. See you
Bye.
soon.
Appreciate y'all coming out.
I'll see you soon.